It's time to continue our Sudoku adventure with Deluxe Hotel Chain by Jean. Um, so let's get into it. Normal 6x6 Sudoku rules apply. So we're going to be placing the digits 1 to 6 exactly once each in every row, in every column, and in every 2x3 box. Outside of that, we have little killer clues. The numbers outside the grid are the sum of the digits that point along the arrow. The digits are allowed to repeat if allowed by normal rules of Sudoku. So let's look at this 15 clue, for example. One way to do that, we could put a 5 in here. Maybe we could put a 3 in here. We could put another 3 in here. It does repeat, but Sudoku would let us do that. And what we're left with there is 5 plus 3 is 8, plus 3 is 11, and we'd need 4. And then that would be one way to make these 4 digits sum to 15. Those are little killer clues. We then have modular lines, and the teal lines in the grid are modular lines. Any three adjacent lines along any three adjacent cells along the modular lines contain digits that are from a different modular group. So this is mod 3, and what this means is a remainder left over when you divide that number by 3. So I'm just going to spend a minute talking about what that means because it's going to be key to the way that we think about this puzzle. If we were to think about the number 1 and divide that by 3, well, that'll be 0. There are 0 3s in a 1, but it'd be remainder 1. If we had 2, it'd be 0 remainder 2. 3 divided by 3 is just 1. It's just 1 3. There is no remainder, so the remainder would be 0. And likewise, 4 5 6. 4 is 1 3, remainder 1. 5 would be 1 3, remainder 2. And 6 would be 2 3s with no remainder. And so the groupings then are these remainders, and it's the output of what they call a mod 3 operation. And in this way, you can see that these two are both remainder 1, so a 1 and a 4 is in the same grouping. Likewise, 2 5s to go together and 3 6s go together. And that is how mod lines work. It means that any 3 digits along the line have 1 each of those groups. So this could be a 1 or a 4, this could be a 2 or a 5, and this could be a 3 or a 6. And then this one would have to be, well, it couldn't be from 2 5, it couldn't be from 3 6, it would have to go back to being from 1 or 4, and that would be a valid way to fulfill the modularity aspect of this line. I can see, though, of course, that those numbers don't add to 10, so this won't be the solution. Those are the rules. If you want to have a go at this puzzle, do have a go. Have a click on the link below. I'm going to take a look now. So, full disclosure, this is my second go at recording this. I did spend a bit of time looking at this puzzle, and I got a little bit stuck. And I didn't think that just watching me staring blankly at the screen for minutes on end was going to be good value. So I paused recording. I reached out to one of the setters, and I give credit to Matt Tressel, who is one of the adventure setters. He tested this puzzle and he gave me something to think about to get started on how to solve this puzzle. So what he said was, think about the mod 3 nature of those digits along the lines, and think about the mod 3 nature of the clue itself. So the first thing to think about is, we've just kind of looked at it. If this is one particular mod 3 type, we'll just call it green. It might be a 1 4, it might be a 2 5, it might be a 3 6, we don't know. But we do know that this digit next to it won't be another green. It won't be another 1 4, 2 5, or 3 6. It'll be a different type, and the third digit along will be a third type. And then, as we just looked at, these 3 have to have 1 of each. They have a purple, they have an orange, so we'd need another green. Okay. And we don't know exactly what the numbers are, but we do know that 10 mod 3 is 1. Okay, so that means that if you take 10, divide it by 3, you'd get 3 lots of 3 to make 9 and another 1. So our target modularity here is 1. So whatever the modularity of this is going to be the same as this, and this will have a different modularity, and this will have a different modularity. And if we add them all up, they need to net out to 1. The number that is the result of these needs to be 1. What does that mean? It means, let's say this is a well, let's go through it. Let's say this is a 3-6 pair, right? But I'm not going to pencil it 3-6. I'm going to pencil the modularity. So 3 divided by 3 is 0. Is 1 remainder 0, and likewise 6 is also remainder 0. So let's say this is remainder 0. We know that in some way, shape, or form, in some order, one of these orange will be 1 and purple will be 2, or vice versa. But we will have a remainder 1 and a remainder 2. So if we add up all the remainders, we actually get 3. So the modularity of this configuration, the modularity, mod 3 of this line, is 0 plus 1 plus 2 plus 0, which is 3. But 3 itself is 3 mod 3 is 0. So this is not the correct configuration, because remember, our target modularity is 1, not 0. So we know that green is not 1-4. Sorry, it's not 3-6. We know it's not 3-6, remainder 0. Okay, what if it's 1? We know that this would then be, in some order, it would be a 0 and a 2. Okay, so what do we add up? 0 plus 2 plus 1 is 3 plus 1 is 4. And again, 4 mod 3 is 1. So that is a valid configuration. And I'm pretty sure, my instinct tells me, I'm just going to case check 2. I don't think this could be from the 2-5 range. If this was 2-5, it would be, they'd both have modularity of 2, a remainder of 2. And that means these would be a 0 and a 1 in some order. Don't know which way around, but it would be 2, 3, 3, 5. And 5 mod 3 is 2, so it's incorrect. So it is remainder 1, and we know that the 2 digits remainder 1 are 1 and 4. So one of these is a 1. In fact, they could both be 1. I'm not sure, but we know that green is from the 1-4 group. And I don't know what these two are. One of them could be one of them could be big, you see. It's not forced to be 2-3. If it were a 2-3 pair, that would be 5, and then we'd have one of these is 1, and one of these would be 4. Or another way to think about it is if they are minimum, if you have 1, 2, 3, 1, you reach 7. So one of these digits has to be big. It doesn't force to be one of these greens. It could be 1, 6, 2, 1. So one of these could be big. But that is from the 1-4 pair, and this is from 2, 3, 5, 6. I'm not gonna pencil that. But I am going to think about this line now, because it's exactly the same. We know what the modularity of these 5 digits are in total. We sum to 15. 15 mod 3 is 0. We know that this digit, whatever it is, will have the same modularity as this one. We know these two will be the same. I couldn't tell you at this stage if they're green or orange. I know they're not purple. Can I tell if they're green or orange? No, I don't think I can at this stage. I'm just going to give them some other color for now. Call them blue. They're either green or orange. I don't know what they are, but I do know they're the same as each other because there are 3 apart along this line, which means this digit, again, let's just give it a color, call it yellow, is going to be standalone. So we have 2 blues and 2 purples and a yellow. So it will come down to modularity of this one. Because if this is a 0, then we know that in some order there'll be a pair of 1s and a pair of 2s. And that works, doesn't it? So 2 plus 1 is 3, 2 plus 1 is 3. That's all that nets out to be mod 0. So I think this is going to be mod 0. I'm just going to quickly check, though, to make sure it doesn't work for the other two. If that's 1, we'll have a pair of 0, 2s. 0 and 2 is 2. Twice makes 4, and 1 more is 5. That is not mod 0. That doesn't work. If that's 2, then that's going to be in some order. That's going to be 0, 1. 0, 1, that's so it's 1, it's 2, it's 4, and that is not mod 0. 4 is 4 mod 3 is 1, not 0. So it's not, so none of them work. It has to be, yellow has to be mod 0. So it's got to be a 3 or a 6. And what does that mean? Oh, it means that it's not, okay, so purple is not green along this line, our original 3 colors. Purple is not green, but purple now can't be yellow. So orange must be yellow. So let's get rid of the yellow and we'll make it orange. And we'll say that orange is 3, 6. And purple must be 2, 5. And purple and orange, so these must be green. These blues, get rid of the blues, they're greens. And they're 1, 4. Okay, that's good. That's progress. So we know that this is a 2 or a 5, a 3 or a 6. We still don't know if that's could still be the 5, could still be the 6. But we're making progress. Oh, I guess I can make this one orange. That's a 3, 6. And this one, okay, so this one is not orange. It's one along from an orange on the line, but it also sees both greens. So this one must be purple, a purple 2, 5, and that will make this one a purple 2, 5, and the other two along this line have to be green 1, 4s. This digit here I can see isn't orange or purple, it must be green. Okay, we are making progress. I can see these 2 oranges, so there's no oranges left in this row, but this digit also can't be purple. And if it's not orange or purple, it must be green. This digit, oh, this digit can't be green and can't be orange, so it must be purple. And the column then is left with 1 more purple. This is going nicely now. This purple has to go somewhere in this box. It can't go in the row. It's not orange or green. It must go there. Now we have 2 purples in this column. So 2 purples in this column, 2 greens in this box. This has to be orange, which, in fact, the box just needed a pair of oranges, so we can put those in. This box still needs an orange, and this column still needs a purple. I've got purples, I need 1 of each of the other 2, and that one is not green because of the row. So that's orange, that's green. We are getting somewhere. This is orange for the row. This row needs 2 purples. This column needs 2 oranges. This row needs a green. And this needs a purple and an orange. But I can't see which way around they go. This needs a purple and a green. This needs an orange and a green. Yeah, I can't see which way around they go yet. So maybe we need to do something else. Maybe the colouring has run out. Can we think about these little killer clues yet? What if we make them small? What if we make them, if we make them big, they're going to be too big, aren't they? So 6, 5, 5, 6, that's already too big. And small is not going to get close, is it? 3 plus 2 is 5, 6, 7, 8, and then 10, 11. No, it's too many degrees of freedom to think about that clue. We've already thought about that one. Is this forced yet? Minimum would be 2, 3, 6, 8, 9. No, there's still 6 degrees of freedom in there. Well, 6 degrees, but actually two big digits and 3 small within their, within their modular groups. So we don't know what that is yet. Maybe we'll look at subcoloring. So if that's a green, maybe this green can actually be a blue, which means this green here makes this one the blue, and that becomes the green. So that one's the blue. If that's the green, that one's the blue, and then that one. Does that help? I think it does, because this, where does the blue go in box 4 now? It doesn't go in this row here, and it doesn't go here. It's orange, so that's our blue kind of green. That's a 1, 4. And now where is the green green? The green green is not in this column or in this row. Let's go here, and there's a pair of greens there. So what are we left with? An orange and an orange, which has to go there, and a purple, which has to go there. I think we're going to finish the colouring now, and then that's purple. So the colouring's done, and yeah, that's great. Okay, so what we're left with now is a green and a blue kind of a green. So one of these is a 1 and the other one is a 4, and that's taken up our degree of freedom. That's taken up our high digit in the low high modularity. So those two sum to 5. 1 plus 4 is 5. These two have to sum to 5, and what we have is a 3 and a 6, which gives us, oops, a 3 and a 6 and 3 and 6. This is going to work across the board, and we've done our oranges. Now, does that look for our purples? Let's see, we've got 2 and 5 and a 2 and 5. And yep, okay, so that is not gonna resolve the 2, 5, so something else will. This 15 clue will help, won't it? This 15, we have 2 plus 6 is 8 plus 2 is 10, and we need 5 more, which gives us a 5 and a 2, 5 and a 2 and 5 and a 2, and they are done. And what we're left with is our greens. It must be the 20 clue. It must be, because I've used the 10 and the 15, so it must be, yeah, that doesn't resolve it. That's just one of each. 5 plus 6 is 11, 12, 13, 14, 15, so that's good. Right, must be this 20. So 6 and 5 is 11, 12, 13, 14, 15, 16, and we need 4 more. So our blue greens, and we can tidy up the blue now. We don't need it because they are 4s. And what we're left with are bronze. Oops. Oops. Undo, undo. What we're left with are 1s. And that's the solution to Deluxe Hotel Chain. So again, thanks to Jean for providing the puzzle. Thanks to Ranks for allowing me to share it with you, and a shout out to Matt for helping me with that logic so I could find my way through it. If you enjoyed the puzzle, I enjoyed this puzzle. If you did, why not give the video a like? Remember to subscribe to the channel and leave a kind comment below. Thanks for watching.